Hi, this is Arpan from Foundation Academy. Today we are going to solve rest of the questions from electrostatics which just came in JEE Mains this February shift. So let's start. Now the first question we start with. A charge Q is placed at one corner of a cube as shown in the figure. The flux of electrostatic field E through the shaded region is, there are four options, so we start with like that. So we have drawn the figure once again, and here the sides which are adjacent to the charges, there will be no flux because there will be no surface area to where these flux lines will go through. So flux through E H G F comma flux through A D E H E D C F equals to 0 as they are adjacent to the point charge Q. Now, flux through the side A, B, C, D, comma, flux through B, C, F, G, and flux through A, B, G, H is not equals to 0 because they are in opposite phase of the charge point charge Q in the vertex E. So we know that flux through any cube is given by phi equals to Q by 8 epsilon naught. So according to this, then the phi of A, B, C, D equals to phi of B, C, F, G equals to phi of A, B, G, H equals to 1 by 3 of Q by 8 epsilon naught. 1 by 3 because the whole flux is Q by 8 epsilon naught, and each of this surface flux will be 1 by 3 of Q by 8 epsilon naught. Then flux through each surface equals to Q by 8 to the 16, it is 24 epsilon naught, right? So here given that only. Now as you can see that the shaded region lies only on two sides opposite to the charge Q, and it lies only at the half portion of each side. So as it lies on half portion of two sides, then we can write as R equals to half of phi of one side, one surface A, B, G, H plus half of phi B, C, F, G equals to Q by 24 equals to half of Q by 24 epsilon naught plus half of Q by 24 epsilon naught. So the result will be again Q by 24 epsilon naught. To the next question, it said that two small spheres each of mass 10 mg are suspended from a point by threads 0.5 meter long. They are equally charged and repel each other to a distance of 0.20 meter. Then charge on each sphere is A by 21 into 10 to the power minus 8 coulomb. Now we have to find the value of A here. So let's start. So here you can see the diagram over here where two spheres which are separated by a distance of r equals to 0.2 meter. Now these two threads will have tension over here, capital T, and T. This T will have two components, T cos theta and T sin theta, in two directions. Now this T sin theta will be comparable with this Fe, this electrostatic force of repulsion between this sphere and this sphere, and T cos theta comparable will be comparable with mg, this gravitational force of this sphere towards towards the earth. So now we can compare it like this: T sin theta equals to Fe, or T sin theta can be written as Fe is the Coulomb's force, and it can be written as k q square by r square, where q is the charge on each sphere and T cos theta equals to mg. So as we find T cos theta and T sin theta, then we can find tan theta equals to T sin theta by T cos theta, or k q square by mg r square, or q square can be written as mg r square tan theta by k. Now from the figure we can say that tan theta equals to zero point 0.1 by zero point 0.5. If we divide the distance between the sphere by 2, we will get the half the distance of the radius r. So we'll get it as zero point 0.1. R by 2, 0.2 by 2 equals to 0.1. From here we get this 0.1, and zero point 0.5 is the length of the thread, and this is 1 by 5. So q square can be found as 10 into, we'll put the values over here. M equals to, it is given in the question, 10 mg, we have to convert it in kg, then 10 into 10 to the power minus 6 kg. So 10 to the power minus 6 into g equals to 10 into zero point 0.2 into zero point 0.2 is the value of r, and tan theta equals to 1 by 5 whole divided by k equals to 9 into 10 to the power 9, and we will get 8 by 9 into 10 to the power minus 16. So q equals to, if we make it square root, we'll get 2 root 2 by 3 into 10 to the power 8 coulomb. So the value of A will be 2 root 2 in this question. Heading towards the next question, it said that two identical conducting spheres with negligible volume have 2.1 nanocoulomb and minus 0.1 nanocoulomb charges respectively. They are brought into contact and then separated by a distance of 0.5 meter. The electrostatic force acting between the sphere is dash into 10 to the power minus 9 Newton. Now, it is given that two spheres, they have different charges, 2.1 nanocoulomb and minus zero point 0.1 nanocoulomb. Now when they are brought in contact with each other, what will happen? The charges will equally distribute among themselves. Then the charge will become 1 nanocoulomb in one sphere and 1 nanocoulomb in other sphere. How? Because it will get equally distributed. Now 2.1 minus zero point 0.1 will get 2.0, and if we divide this with 2, we'll get 1 nanocoulomb, right? So the charge will equally distributed in these two spheres. As it is given in the question, these two spheres are now separated by a distance of 0.5 meter. That it means r equals to 0.5 meter. Now if we find the electrostatic force which is given, which we need to find in the question, so we know all of us know the formula, k q square by r square, where k equals to 9 into 10 to the power 9, and Q it is given 1 nanocoulomb. 1 nanocoulomb equals to 10 to the power minus 9 coulomb. 1 into 10 to the power minus 9 coulomb by r square point 5 square. And when after finding after solving the whole problem, we'll get minus 9. Therefore, Fe equals to 36 into 10 to the power minus 9 Newton. So answer is 36. Heading towards the next question, it said that a current of 6 ampere enters one corner point P of an equilateral triangle PQR having three wires of resistance 2 ohm each and leaves by the corner R. The current I1 in एम्पेयर is मतलब कि यहाँ पे हमको I1 निकालना पड़ेगा. So let's start. So you can see that we have drawn the equivalent resistance where we have made we know that PQR there is two resistance over here, this part and this part. These two resistance are in series, so we can say we can draw an equivalent resistance, this 4 ohm. How? If we make these two in series, then we will get 2 plus 2 equals to 4 ohm, which is the equivalent resistance, and we have drawn the equivalent circuit over here. Now what we will do, we'll apply KCL over here. So applying KCL, we can write that I minus I1 equal into R2 equals to I1 R1, because I2 equals to I minus I1. So or I R2 minus I1 R2 equals to I1 R, sorry, this will be 1 R1, or I R2 equals to I1 R1 plus R2, right? Or we can write I1 equals to R2 by R1 plus R2 whole into I. Now we know that R1 equals to 4, we have find it in equivalent resistance, and R2 equals to 2 and R2 equals to 2 and I equals to 6 ampere, which is given in the question. So we'll get, after solving this, we'll get 2 ampere. So the result, I1 equals to 2 ampere. So heading to towards the next question, it said that find the electric field at point P on the perpendicular bisector of a uniformly charged thin wire of length capital L carrying a charge capital Q. The distance of the point P from the center of the rod is A equals to root 3 by 2 L, capital L. Root 3 by 2 into capital L. Now you can see the diagram. I'll draw the diagram again. So let's start. Now as we can see, we have drawn the diagram. This whole conductor is of length capital L, but we divided into two parts. From the center it will be L by 2. Now the distance between this point and point P from the center is root 3 by 2 into capital L. Now these two ends of the rod is subtended by an angle of theta. If we consider it as theta, then from diagram we can write that tan theta equals to L by 2, this perpendicular, this L by 2, and this base root 3 L by 2, and we'll find that tan theta will be the value of tan theta will be 1 by root 3. So theta will be what? How much? 30 degree. So this net electric field will get as k lambda, as we all know the formula, k lambda by root 3 L by 2 sine 30 degree sine theta plus sine theta, or we can say that sine 30 theta equals to 30 degree, k lambda 2k lambda by root 3 L sine 30 degree plus sine 30 degree equals to, what you can write, 2k q by root 3 L square. Now sine 30 equals to half plus half. As we know, lambda equal is, what is lambda? Lambda is linear charge density, and we can write as q by capital L. Now half plus half equals to 1. So now if we put the value of k over here, we'll get root 3 L square into 1 by 4 pi epsilon naught. If we cut 2 and 4, we'll get 2, that is q by 2 root 3 pi epsilon naught L square. So the correct answer is number 1. Heading towards the last question, it said that in an electrical circuit, a battery is connected to pass 20 microcoulomb of charge through it in a certain given time. The potential difference between two plates of the battery is maintained at 15 volt. Now, what is the work done by the battery in joule? So we'll draw the battery like that, and if it is given to 20 microcoulomb charge, and it creates potential of 15 volt in this, between these two plates, then we can say that work done equals to charge into potential difference. As we already know, this formula, 20 into 15 equals to 300 joule. So you can see that this question is very easy, and this answer is nothing but 300 for here. So I think these questions are helpful to you. Thanks for watching. If you like this video, please like, share and subscribe. Thank you. For more queries, contact to Foundation Academy 75 at the rate gmail.com. Thank you very much.